Welcome to the fourth day of Java programming course. So before we start off with operators and precedence and associativity rules, one clarification about the data types and their sizes. So actually there is more to it, okay? I have just given you an overview of how it works and what are the ranges, sizes and all. Now suppose this case, so suppose in this case, you have short a equal to its maximum limit, that is 32767. Okay, we know that the range of short data type is minus 32768 up to 32767. So suppose I give here just one more, that is 32768. As you can see, this red line has been indicated here, means it is highlighted, means it is indicating about an error. Okay, because of the IDE that you're using. And what some suggestions also it will give, like casting operation, migration or conversion of some data type. Okay, so you can either go with that option, or what you can do is you must maintain the range. And suppose there are two such variables. Okay, there are two short variables, both are at the maximum limit, and suppose I add them and I store it in another short variable, then definitely the sum of 32767 with 32767 will go beyond the range. So what will happen? You should get a error message or some warning sort of. So what it is saying, required type is short, but you're providing int. Okay, here you can see required short provided int. Required short means at the right hand side, the range should be within short, because at the left hand side it is short, right? If the range at the right hand side is less than equal to short, then it is okay. But if at the right hand side the range is going above short or beyond short, then it will give you an error, right? We have seen that last time. So it is saying that it is required as short, but this range that you're giving, 32767 plus 32767, actually comes in the integer range. Okay, that is why it is telling that it is required as short, but you have given int. You have given int means how? Because the sum of a and b is in the integer range. So it is telling given is int, but required is short. Okay, so such messages you may come across, and you should understand what it means. So what is the solution is, as they have said, cast to short. Typecasting means temporary conversion from one data type to another. So see, now the error has gone. So this is the way of typecasting, means type conversion. So what happens? A plus B is integer range actually, but you're forcefully converting it into the short. Okay. So definitely there will be some data loss, right? Because the size of short is lesser than integer. And one more thing is, if you run such a statement, you will not get the desired output. For example, let me run it and show you now. It is building. I need to also print this. So as you can see here, you're getting -2. But 32767 plus 32767 is not -2. So actually what happens, I'll show you over here. Consider byte, okay, for simplicity, let's consider byte. Do you remember what is the range of byte? Anyone? It is -128 to 127. So if you consider this range, so what is it actually? It is some negative range and some positive range. So if you consider only the positive part, it is from 0 to 127. Okay, 0 is considered in the positive range for the distribution. And if you consider the negative side, what it is including -128 to what? -1. But what is the requirement, or how it should be is, it should be equal distribution. Means at the right hand side you have 128 number of values. 0 to 127 means these are total 128 values. And at the right hand side, -128 to -1 is total 127 values. So there is one less at the left hand side, negative range. So to equalize that, what happens is there is a minus 0, but actually there's nothing like minus 0, right? So what happens initially when you do minus 1 to minus 127, okay, means consider 0 to 127 and minus 1 to minus 127. So if you want to include minus 0 also in this range, so that we have equal on left hand side and right hand side, that is not correct because we don't have anything like minus 0. So to accommodate that minus 0, what happens? You accommodate it as minus 128. Okay, so there are many such things that actually happen internally which you do not need to do on your own, and because of that, minus 0 is getting represented as minus 128. Okay, so such things happen. Actually, this a detailed video needs to be prepared on this topic. So maybe it will get confusing at this time if I explain all these things. There is one more concept like why float is represented in exponential way. For example, if I show you over here, you might have seen the range of float. I'll just show you. See, float also we write 0.0 f. So that f is also why we need to write that also I need to tell you. And then in this operators, the range is usually expressed in exponential form. For example, in some books or maybe in Python also you would have studied that float is represented like this. Suppose 3.2 into or maybe E10. Okay, you will see something like this for the size of float in some books. E10. E10 means what? It means that it is nothing but into 10 raised to 10. Okay, 10 raised to 10. Whenever you write E10, it means exponent is 10. And what is the base? It means 10 raised to 10. Okay, E10 means 10 raised to 10. Similarly, if I say E5 means 10 raised to 5. If I say E16 means 10 raised to 16. So how this is coming is, if I say 80.35, now computer cannot store, how will it store the decimal point like this in the memory? Okay, so what will happen is you have to shift this decimal point to the left. Okay, this is just additional information I'm telling because someone asked me the question about this. And then this point will come here. That means you have divided by 100. 80.35, when you divide by 100, the point will shift ahead, right? Am I right?
Yes.
Yeah.
Yes.
So if it shifts to the left, means you have divided by 100, means you also need to multiply by 100. Means you need to multiply by 10 raised to 2. 10 raised to 2 is what? E2. So that is how this E comes in between. And that is why the range of float sometimes is expressed as E14 or E15 like that. So this is how the things happen. And why float it is called? Because this decimal point was between 80 and 35. It was 80.35. That decimal point has floated ahead. Okay, it has floated ahead. That is why it is called as float data type. So many such things are there which are in much depth. Okay, like how minus 0 is nothing but it is represented as minus 128 to have equal range on left and right hand side. So all such things are there. That is why if you also consider one more example that I want to give you.
Sorry to disturb, sir, but some students are waiting.
Yes, I was concentrating on that, right? So I didn't pay attention. Yeah. So I'll just open my whiteboard. Okay, so these are some points that so that you understand that why you're getting such wrong outputs. Actually, it is not wrong. It is because of the characteristics that I used to design the data type. Okay, so if you consider char data type in C++, actually how it works, I'll show you how. So actually, I didn't want to talk about all these things, but then if you get this doubt, then it is not correct to ignore it, right? So suppose you have a circle over here. You start off from 0, then you go to 1, 2, 3, so on. You'll go up to 127. Okay. And then before 0, what you have? Minus 1, then you have minus 2, and so on. You'll go up to minus 128. Okay, sometimes what happens, if your value is 128 or if it is positive 130, then what will happen? Minus 128, then you'll go to minus 127, and so on. You'll go throughout. Means this is circular, means there's no end to this circle. That means if there is only up to positive 127, what about positive 128? I have not mentioned. So what will happen? I'll go ahead in the circle. So this is how, if the range is not available, it gets converted to some other range. Okay, so this actually I need to prepare a separate video to make you understand all this. So that is why when you're writing over here, you're getting -2. Okay, it's going to some other range because after 127, you don't have any other positive value in case of byte. Similarly for short, that is why it's going to -2 or -1. It may go to -30 or anything else. So why it is happening actually? Because the range is not sufficient to accommodate the result. What the result is here, something 64,000 or something like that, which is not coming in the range of short. That is why you're getting such other values which is going outside the range. So what you must remember, if the range is going outside, either you'll get an error, like how in case of short what happened, it showed this red line, but in case of int it will not show that red line. Okay, in case of int, see, this is the maximum range for int. One, this is the maximum range for int. If I add a plus b, the range will go beyond the integer range. But you're not getting a red line here. It's not highlighting. So what does that mean is, either you'll get an error, the red line, or you'll get a undesirable value like -2. Right? If I do here a plus b, okay, then what will happen? Let us see. You should get -2. Because as I said, it's going outside the range. See, you're getting -2. So what is the remedy? You must use long to accommodate the result. So now if you use long and you print the value, you will get 4 something something. See, you're getting 429496. Okay, so this is the reason, because the range is not possible to accommodate. Either you'll get the error like in case of short, or in some cases you may get -2 or -30, though it is the wrong answer. So is this clear? We will talk about it in detail in future, but for now you can
Yes.
understand this much. Is it okay? Okay. So this was a little bit about that. Now let us start off with our actual topic. So today actually we have to see operators. Okay, so we have seen this introduction last time. Now in arithmetic operators, for example, where is that? Okay, so I'll show you the examples of arithmetic operators over here. And now operators can be classified as arithmetic, bitwise, logical, relational. You might have seen this in Python. And they're also classified based on the number of operands. For example, if you're doing a plus b, then a is one value, b is one value. So two values, in between that you're doing addition operation. There may be a case where you're doing a plus plus or a minus minus. That is unary operation. Means on a single value a, you're doing an operation of plus plus or minus minus. Similarly, between three operands, you can do it. So based on this, you are classifying the type of operation. Either it is for a single operand like a plus plus, or it is a plus b between two operands or two values, or it is between three operands. So that is about the number of values between which you're doing operation. And what is the other classification? Other classification is based on the operation. That is whether you're doing addition, subtraction, that is arithmetic operation, or whether you're doing comparison operation like a greater than b, a less than b, or maybe you're doing assignment operation like a plus equal to b. So based on that, there are two classifications. We'll see some examples now. Arithmetic operators, you already know: plus, minus, multiplication, division. Okay, you don't have floor division over here as you had in Python. And one more thing, in Java, uh, when we were studying operators last time, I told you that this modulus operator cannot be used for floating point values or doubles or other values other than integers. That is true for C, C++. Okay, but for Java it is allowed. Means if you do 1.2 mod 2.3, it is allowed. Okay, we'll see that example in our program. But you remember that in Java, you can use this percentage or modulus for floating point division. Means your numerator upon denominator, numerator and denominator, if they are floating point values and you're using mod, it is okay. Then plus plus and minus minus, we need to see examples. Okay, I'll send you these notes. Before that, let us see some practical examples. If when you're doing x plus plus, it is nothing but it is same as doing x is equal to x plus 1. And when you're doing plus plus x, it is same like doing x is equal to x plus 1. But there is a small difference. Now, first of all, tell me this x plus plus, is it a unary operation or is it a binary operation? On how many values you're doing this operation? On say a single value or on two values?
Single value.
Single
Single
value.
value.
So it is,
Single
yes,
value.
correct. So it is
Unary.
unary operation because there is a single value on which you're doing some operation. Now, what is the difference between x plus plus and plus plus x? For
Post
example,
increment and pre-increment.
yeah, that is correct. So suppose you have 3 lines of code in your program. Initially, you're writing x equal to 12. Okay, int x equal to 12. Then next line you're doing x plus plus. And suppose you have another variable b, or let me take y, and you're putting the value of x plus plus inside y. Means you're storing x plus plus inside y. And on the next line, suppose you want to print the value of x and y. Okay, so first I'll print x, and how to print multiple values using a simple println statement that we'll see later. Okay, I'm printing x and y. Now what should be the output we'll discuss now. See, x is equal to 12 initially. Then when you do x plus plus, it means post increment. Plus plus means increment. Increment is nothing but increase by 1. Increment means increasing by 1. So if x is currently 12, increasing by 1 means x will become 13. So now x plus plus means first you use the current value of x. What is the current value of x? Means at the moment x is equal to 12. So that value 12 will get stored inside y. So I'll write in a comment for you to understand. I'll write y equal to 12. Okay. So the current value of x is 12. That will get stored in y. And after this, on the next line, or maybe after storing it inside y, what will happen? After storing that 12 inside y, then x will become 13. Okay. So this is the difference. Current value of x, you use it in the expression, or you use it in line number 2. Current value of x you use in line number 2, and next or on the next line the value of x will be 13. Then similarly on line number 3 it will be 13, line number 4 x value will be 13, and so on. So if you print out x at line number 3, the value of x will be 13, and if you print out y on line number 4, value of y is what? 12. Did you understand this, how we are doing the post operation? Everyone?
Yes.
Should I repeat for anyone?
Yes, sir.
Should I repeat?
Yes, sir.
Okay, okay,
Yes, sir.
okay, okay, okay. See, what I'm saying is currently x is equal to 12. Okay, that current value means at the moment x is equal to 12, that value 12 will get stored inside y. Okay, that same value of x will get stored inside y, and then next line or after storing that value inside y, from the next line onwards x will become 13, because plus plus means increasing the value of x by 1. So what I mean to say is use the current value of x in the expression and then increase the value of x. Okay, so I'll show you pre-increment also, then the idea will get clear, I suppose. See what will happen in pre-increment. You have the same number of lines. Let me place it side by side. See, now x is equal to 12 and I'm doing y is equal to plus plus x. Now in this case, how it works is different. Let me erase this. See, plus plus x means the current value at the moment x is equal to 12. So first you will increase the value of x. Means it is a pre-operation. Pre means before. Means first what you'll do, you'll increase the value of x. So at the line number 2, the value of x is nothing but equal to 13. Okay, it has been increased. And this new value of x, okay, the new value of x will get stored inside y. And now from line number 2 onwards, x will be 13 only. So at line number 3, if you want to print the value of x, it is 13. And at line number at line number 4, the value of y, that is 13. So did you get the difference? See, in pre-increment, what will happen? First increase, first increment. So what will happen? X will become new value 13, and that new value you will store inside y. But in post operation, what we were doing, whatever the current value of x is, that will get stored first inside y. And afterwards, post means afterwards, you will increase the value of x to the new value. So as you can see, here y is equal to 12 and x is equal to 13. But here y and x both are equal to 13. Is it clear now?
Yes, sir.
Others, what about others?
Yes.
Yes, clear.
Yes, it's clear.
Yes, sir.
Okay. So next we have some questions that I would like to show you. So same thing I've written here. Okay, so let us solve this question now. So I'm writing int y equal to 7, then int x equal to plus plus y into 8. Int x equal to plus y into 8. You can try to solve it now on your own, and then like when I ask you, you can tell me. And then we want to know the value of x. So I will print the value of x. And let us also print the value of y. So does anyone want to give the answer if you have solved it on your own? What do you think? You can also guess the answer if you want.
Yes, 64, 64 and y.
64.
64 and 7.
Okay, so you are
64 and
saying
8.
that. Okay, so you are saying that x is equal to 64 and what should be y?
8.
Okay,
8.
let us see. So what is happening? First y equal to 7, that is simple. Then x is equal to plus plus y into 8. Now see, there are two operations. First is plus plus y and then this value into 8. Okay, so always remember, whenever you have a plus plus y or a y plus plus, or whether you have a minus minus y or y minus minus, those will be performed first because they have higher priority than your normal plus minus multiplication division. Okay, so first plus plus y will happen. So this is what pre-operation. Pre means what? You have to increase the value of y first. So at this line, y will become equal to what? You have to increase the value, so y is equal to 8. Okay, first increase, that is y is equal to 8. Now use this value of y inside the expression. So 8, so here plus plus y is nothing but 8. 8 into 8 is what? 64. So x value will be what? 64. So now when I print out x, should be 64 as you said. And when I print out y, it should be 8 as you said. Let us see. So you were correct, 64 and 8. Okay, so good. It was a good attempt and you've given the correct answer. Similarly, if I have y plus plus, what do you think? Can you tell me the answer?
56.
56
What
Y
is
is 8
56?
and 7.
7 and
56 7.
Y equal to
So
56.
56.
and y is equal to
X
7.
is
Okay, let us see.
8.
8.
Y
Okay.
is
Y
equal
is
to
equal
8.
to 8.
Okay. Let us see now. So y is equal to 7. That is okay. Now y plus plus means it is post operation, means what afterwards you have to increase the value. So first you use the current value of y. That means y plus plus is nothing but it will get replaced with 7. 7 8s are 56. So x will become equal to what? 56. And y value will be what? You use the current value. Now you have to increment. So y will become what? 8. Okay. So 56 and 8. Right? Am I right?
Yes.
Okay.
Yes, sir.
So as you can see, 56 and 8. Similarly, we can have y minus minus also. Now in plus plus, what we do? We increase the value. So in minus minus, what we'll do? We'll decrease the value. Can you guess what will be the answer now?
56 and 6. Sorry.
Okay, let us see. 56 and what?
6.
6.
6. Okay. So y is equal to 7. Now afterwards, you will decrease the value. Use the current value of y. Current value of y is what? 7. So 7 8s are 56. X is 56. And then y is what? You used it as 7. Now you will decrease the value. So y will become equal to 6. Okay, so let us run this program. 56 and 6. Similarly, you can try out other cases. Now sometimes what happens is they'll give you plus plus x divided by 67 modulus 5. So such big complex expressions they'll give you. For that you have to apply certain rules, like which one you'll solve first and all that. So that I'll cover in some other video. And I have already solved some number of examples on this in my previous course. So the logic is same, right? So I'll share those videos with you, or maybe we can solve it live also. Let's see. So this was about plus plus minus minus. If you still have any doubt, you can ask me in the doubt session that we have at the end. Okay, so now this was about the arithmetic operators. Then you have greater than, less than. Now, can you tell me when I'm comparing A less than B? So what will be the values? It will be either the comparison may be true or it may be false. Okay, there's no other option. Either A, yes, A is greater than B, or no, A is less than B. Means what I mean to say, there are only two possibilities. When you're doing A, some comparison like greater than B, the answer may be either true or false. Is there any other possibility?
No.
Yes, no, no. Okay, that means there are only two possible values. So whenever you use a comparison operation, either the output will be Boolean value, that is true or false. So you know all this, right? Less than, equal to, and all that. You have already studied. Do you want me to explain all these cases, or you already know it? You all know it, right?
Yes, sir.
Yes.
Because we have got a lot to cover, so I don't want to spend time in explaining what you already know. Now, this logical operations, you know about and, or, not operations, okay? That we will see. Then these are the bitwise operations. Means when you apply this, value operator, for example, a single ampersand. Okay, so you have, when you're writing double ampersand, means ampersand ampersand, it stands for a logical operation. When you write these two vertical lines, it is called as pipe actually, and it is standing for or operation. And this exclamation mark is nothing but for logical not operation. The same like a logic gates. When you write a single and, or a single pipe, or a single caret, this is called CARAT, or maybe the tilde sign. So these are bitwise operations. Bitwise operations means whatever is the value of A, suppose A is 12 and B is 16. So internally, automatically, implicitly, 12 will be converted into its binary format, that is 1100. I'm sure you know how to do this. And 16 is what? It will be 1 0 0 0 0. Okay. So when you apply the AND operation, it should be done bit by bit. Means this 0 and this 0, this 0 and this 0, this 1 and this 0, this 1 and this 0, this 0 and this one. So one by one you're doing the operation. So 0 and 0 is 0, 0 and 0 is 0. Then what do we have? 1 and 0 is what? 1 and 0 is what?
0.
Yeah, 0. Again 1 and 0 is 0.
0.
Again 1 and 0 is 0. So
0.
when you solve this, yeah. So when you print out the value of A and B, that is A bitwise and B, when you print out the value of this expression, what you'll get, you won't get all these 5 zeros, you'll get it into single zero. Why? Because what is happening in the background, 12 is getting converted to binary, 16 converted to binary, operation is performed at the bits level, and then final answer is converted back to your normal integer or decimal, and that value will get displayed. For example, 0 will get displayed. Okay, so what will happen? Decimal to binary, perform the operation, and then binary to decimal. Okay, so output will be in decimal only. So I hope this was also clear. Similarly, you can do A bitwise or B. You know all this how to do. Okay. Similarly, left shift, right shift, we'll see in our program. And then this equal to, plus equal to. Okay, so when you write C plus equal to A, it is nothing but same as writing C is equal to C plus A. So when I write, for example, A plus equal to B, it is same like saying A is equal to A plus B. So what is the meaning of this is left side plus equal to right side. So what will happen? Left side is equal to left plus right. Right? Same thing we have done here. Instead of left we have A, instead of right we have B, and same thing we have done. Suppose I say X mod equal to Y. Then what should be the value of X? X is equal to X mod Y. So first of all, X mod Y will be performed. Whatever is the answer, suppose 12, that 12 will get stored inside X. So this is the meaning of this shortcut. Instead of writing A is equal to A plus B, write A plus equal to B. Now also remember, there are a few ways of doing the same thing. If you want to increment the value by 1, either you can do A plus plus, and according to your choice, you may do plus plus A, or you may do A plus equal to 1. A plus equal to 1 is what actually? It is equal to, it means that A is equal to A plus 1. You may also want to do, maybe you have written B equal to 1. Okay, and then you're doing A plus equal to B. Means what will happen actually? It is nothing but A is equal to A plus B. What is B? B is 1. So it is nothing but you have increased the value of A by 1. Then there is a possibility that you may directly write A is equal to A plus 1. So all these are, your intention is to do the same thing, increasing the value of A by 1. Have you got all these ways of doing the same thing?
Yes.
Okay. Similarly, left shift, right shift, you can do by this shortcut, which we'll see in our programs. Okay. So let us see the programs now. Just hold on for a minute. So here we have done the same thing. We have a variable res and we are writing equal to a minus minus and is equal to a plus 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 a. So we have just now solved an example like this. So see here, actually in C language, this is a program in C language. For that you use printf statement. Okay. But in Java, what we use system.out.println. So the intention of this printf is to do the same thing that system.out.println does. Okay, it is the same thing. But what I'm doing here, see, a is equal to 10, b is equal to 20, a less than equal to b. Okay, so the answer will be what here? It will be in the form of a Boolean value. So 10 less than equal to 20 is true. So the output should be true. Okay, so such small programs you can also execute at your home. And then here you have 1 and 0. Now I'm writing 2 times ampersand means what? It is logical AND operation. So 1 and 0 output is 0. Okay. Now just a minute, I'll reshare my screen. Okay, so here I've displayed the truth table of the AND, OR, and NOT operations. So the truth table, what it is, if you have 0, 0, so 0 and 0 is what? 0. 0 or 0 is 0, and 0 XOR 0 is also 0. Okay, so here you get the truth table for all the logical operations. If you have 0 and 1, the answer is 0. 0 or 1 is 1. 0 XOR 1 is 1. XOR is nothing but can someone define what is XOR operation? Do you know about it? What is XOR operation? So XOR operation is nothing but, I'm audible, right?
Yes, sir.
Yes.
Yeah, so XOR operation is nothing but it says that if A is true or B is true, but not both, then the output is true. Means what? Here you have A and B, and suppose you want to write the output of XOR operation. That means A, this is the symbol for XOR in programming, B. So if A is true or B is true, but not both, then the output is true. Here both are false, that means output is false. If A is false and B is true, that means any one is true, okay, any one is true between A and B, then the output is true. If any one is true, in this case A is true, B is false, then the output is true. But if both are true, then the output is false. So when is the output false? When both are false, or if both are true, the output is false. Okay, if both are false or both are true, then the output is false. If any one is true, then output is true. So this is what is happening in that table. Okay, so you can go through this, then okay, so now let us see some other example. Suppose you have left shift operation. Suppose 6, you're doing right shift 2. Okay, means A, right shift B. Okay, in this format you're doing. So what happens is, this shifting operation is a bitwise operation. Means for 6 you have to convert to its binary form. What is the binary equivalent of 6?
0110.
Yes, 0, 1, 1, 0. What is the binary of 2?
0, 0, 1, 0.
1, 0.
Yes. Now 0, 0, 1, 0. If you're doing AND operation between this, then the right hand side, that is B, will be converted to binary. If you're doing OR operation, then B will be converted to binary. If you're doing XOR operation, then B, that is 2, will get converted into binary. But in case of left shift, right shift, what happens? The meaning of this operation is you want to shift the bits of the 6. You want to shift the bits of 6 towards the right by 2 places. So you don't actually need to convert 2 into binary. So what do I mean by this is, right shifting the bits by 2 means how it will happen is, this 0 will come here. Just a minute. Then this 1 will come here. This 1 will come here. So what has happened now? This 0 has come here, so 0. This 1 has come here, so 1. This 1 has come here, so 1. And this 0 will come again one step ahead here. And whenever you do this, here you have a blank space. So wherever there's a blank space, 0 will come automatically. This was one time we shifted all the bits. Now second time we have to shift the bits. Why? Because we want to shift by 2. We want to shift B times. B times means 2 times. So again, what will happen? This 0 will come here. This 0 will come here. This 1 will come here. This 1 will come here. And this 0 will come here. So what happened now? This 0 has come here. So everything will move towards the right by 1. And now here you have a blank space. Here 0 will come. So what is the final output is 0, 0, 0, 1, 1, 0. That means if you apply your 8421 code, so this is 1, 2, 4, 8. So this is what? 4 and 2, 6. And this is 1. But you always remember that when you're shifting towards the right, you will not consider if it is going outside the frame. Means you have to consider only these 4 bits. Okay, so these 4. This 0, which we shifted here, has gone outside. It is gone now. You will not consider. Similarly, this 4 only you have to consider. So whatever is going outside the frame, that will go away. So this is what now? 0, 0, 0, 1. This you have to consider is nothing but 1. Okay. I'll explain this one more time. For the value 8, suppose. So 8 is nothing but 1, 0, 0, 0. And we want to shift it by 2 places. That means 8, right shift 2. So how will it happen is, first you will shift everything towards the right. So this 1 will come here, this 0 will go here, this 0 will go here, and this 0 will go outside. So 1, 0, 0, 0. So this 0 is cancelled now. Don't consider that. Now again shift everything by 1 place. So this 1 will come here, this 1 will come here, and this 0 will come here. So 1, 0, 0, and this 0 which we cancelled. So whatever is outside, cancel it. Don't consider. And wherever you have the blank space, you can put the 0 there. Means automatically 0 will come there. So when you shift 8 towards the right by 2 places, the answer is this one. That is 0, 0, 1, 0. That is the answer is 2. So when you print the value of 8 right shift 2, the output is 2. Did you understand this?
Yes.
Everyone?
Yes.
Okay. Now let us see left shift. So suppose 8. This is for left shift 2. So again consider those 4 spaces only. Now what is 8? 1, 0, 0, 0. You will shift this towards the left now. Means when you shift it towards the left, this 1 will go outside, this 0 will come here, this 0 will come here, and this 0 will come. So what it becomes 1, 0, 0, 0. And wherever you have a blank space, there what you'll put? Yes, anyone, what you'll put?
0.
0.
Yes. Okay, then again we want to shift because we want to shift in total 2 times. So this 1 will get shifted, this 0 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 will get shifted. So finally the output will become, this 1 has come here, this 0 has gone here, this 0 has gone here, this 0 has gone here, and this is your 0 and 0. So now what is remaining with you? Whatever is outside, cancel it, don't consider. The total value will be 0, 0, 0, 0 is nothing but 0. So this is left shifting. So whatever is going outside your 4 bits, that you have to cancel. Now you may ask, why only 4 bits? See, minimum you need how many bits to represent 8? You need 4 bits. Similarly, minimum to represent 16, how many bits you'll need? According to your 8421 code, what will it become if you're using 16? 16 8421 it becomes. Powers of 2. 2 raised to 0, this is 2 raised to 1, this is 2 raised to 2, this is 2 raised to 3, this is 2 raised to 4. Similarly, if you want to have 32, it is 2 raised to 5. So minimum to represent 16, it will be 1, 0, 0, 0, 0. Means minimum you need 5 bits. So we are considering that minimum number of bits. For 8, you need minimum 4 bits. Okay, have you got this? Why 4 bits when you have to consider 5 bits and all? Is it clear?
Yes, sir.
Yes.
Yes, sir.
Everyone? Okay.
Yes.
Okay, so actually what happened, I wanted to play those these detailed videos here, but unfortunately I'm not able to share the audio of the video right now. Earlier it was possible, but I don't know why it's not allowing me now. So I'll send you the video and you can go through it in detail whenever you're free, okay, at home. So this was about left shifting and right shifting. Then what else do we have? We have data manipulation. And after that we will have logical operation. Okay. So now let us see some programs in Java. So see here, arithmetic operation you want to perform. So int a equal to 4. Let us take positive 6 for now. 6 mod a. So 6 divided by 4, but it is not the, see when you do 6 / a, it will return the quotient. And when you do mod, it will return the remainder, okay? And this is a very important logic that you'll use in your Armstrong number program. Have you all executed Armstrong in your Python program in first year?
Yes.
Yeah, so we'll see that in Java as well later on. So here you have 6 mod a. A is what? 4. 6 mod 4. Now 4 ones are 4. So the remainder is 2. So they should print out 2. So the value 2 will get stored in B. Okay. Okay, so I have to execute this file. So see, A is what? 4. B is what? As I said, 2. The remainder of the division. And now, as I said, you can use floating point numbers to find the remainder as well, okay, in Java, not in C, C++. So it will return 0.3999 something. Now, by default, the answer, that is the remainder, will also be a floating point value. So float divided by float, the remainder, quotient, everything will also be a float. Okay. Even if the remainder is 2, it will print it as 2.0. Okay, because everything should be in the float, fractional value. Now I'm saying float, but by default, the value is considered as a double value. Why? Because double has higher precision than float. If I want to show you the difference between float and double, just a minute. So float and double, the difference is whatever fractional value you store inside float, it will be represented with lesser precision, And whatever fractional value you store in the double type of data type, it will have higher precision. For example, if I want to store the value, this one 3.14159C, it's a very big value. I want to store it inside A. A's data type is float and the data type of B is double. Same value I'm going to store in float and double. But when I print out A and B value, when I print out the value of A and B, see the difference. If I print out the value of A, what is the thing? 3.1415927. Okay, see here 927. But when I was initializing A, what is it? 9265 something something. But at the output, what I'm getting? Some different value. Okay, can you see the difference? When I'm storing the value of A inside A, I'm storing 926. But when it is printing the value of A, it is printing 927 something something. And the value is changing after that. Is the difference visible to you?
Yes.
Yeah. Similarly, in double, I'm storing the same value. See here, 926. And here also it is 926. And after 926, what we have? 535. 535 is there at the output also. Then 897. 897 is also there at the output. Then 932, we have 931. Means as you can see, after a very long time, you're getting the change. You're getting something different. But in float, the value is less precise or less accurate. You have stored something, but you're getting something else. But double is more accurate, right? Do you agree with me?
Yes.
Yeah, so this is the difference between float and double. How accurately the value is getting stored in the memory. You may store something, but you will get something else. Okay, but double is more precise. So as you can see here you're getting a number of digits after the decimal point. So this was one program about arithmetic operators. Now this is for assignment operator. What we are doing here, int b equal to 9, b asterisk equal to 3, means it is nothing but b is equal to b into 3. So this is nothing but b is equal to, what is the current value of b? Can anyone tell me?
9.
Yes, 9 into 3. 9 into 3 is what? 27. So the value of b will get displayed as 27. Then comparison operator. So let us run this comparison. The output will come in terms of true or false. See, false, because 64 less than 6 is false. Okay, so falsity. Similarly, here there's a combination of operations that we want to do. For example, expression 1 and expression 2. Not necessary you will always have A, then at the right hand side you'll have B, and simply A and B want to do. Not necessary. At the left hand side, expression 1 may be some complicated expression. In this case, it is 64 greater than 5. It may be something like A plus B into C minus D something something and something something. Okay, not necessary single values. You can have expressions at the left and right hand side. So what happens in the video that I was talking about, I've explained in detail when and what, how everything is explained. So those videos you can see, logic is same. That is why I don't want to spend time in explaining. Similarly here, it is a single value, bitwise and single value. So here it will work in, it will first convert 2 to binary, 5 to binary, perform the operation. Whatever result you get is binary. That binary result will again get converted into decimal. This was about operators. Any doubt till here? Anything you want me to repeat? Anyone?
No.
Others?
No.
Okay. Now operator precedence and associativity rules are because it is because suppose you have a combination of operators. For example, in mathematics, we follow a famous rule. What is that rule? BODMAS. For example, A plus B into C divided by 2. So what happens here? We'll first find out the highest priority operation. That is according to BODMAS division. So we'll do C divided by 2 first. Suppose we get X. Then what is having higher priority between plus and multiplication? Can you tell me?
Multiplication.
Multiplication.
Yes. So you'll solve B and X. See, multiplication is between which two values? Between B and X. So that you'll solve first. Between whichever values the asterisk or multiplication is found, that you'll solve first. Suppose you get Y. Then finally you'll do A plus Y equal to 12, suppose. So you have to find out that which operation you'll perform first. Otherwise you'll get wrong answer. For example, 6 plus 2 into 4. And if I do 6 plus 2 into 4. Now, according to the BODMAS rule, I'll first do multiplication. That means this will become 6 plus 2 into 4, 8. And then it will become 14. Here, what if I do 6 plus 2 first, what will happen? 6 plus 2 is what? 12. And then 12 into 4 is nothing but 48. So as you can see, if I do the wrong, if I give the order of operation wrong, if I do not decide which one to do first properly, if I do anything first, anything last, then I'm getting different output, which will be wrong. So that is why we need to follow certain rules. In mathematics, we will solve the question paper, so we have to know the rules. But here the computer will solve the calculation, so the computer already knows the rules. Okay, you do not need to specify the rules. So that rules are automatically known to the computer, and he will solve it properly for you. But being a programmer, you should know, because in questions in your SPPU paper or in your interviews, they'll give you a long expression, A plus into B something something, and that time you won't have a computer to solve with you. You have to understand what will be the output. You have to solve it step by step and all. So whatever the rules the computer follows, you have to follow to get the correct answer in the program. Okay, so we can stop here for now, and you can quickly put your attendance in the chat box. So next time what we are going to see is how to apply the rules to solve a big combination of operations. Any doubts still here? Anything else you want to ask?
No, sir.
Okay, then if no doubts, you can leave this meeting. Thank you.
Thank you, sir.
Welcome.
Thank you, sir.
Welcome. Welcome.
Thank you.
Welcome.
So,
Yes.
how to do bitwise not of 40?
Okay. So bitwise not. So bitwise not, the symbol is this one. Okay, this is the symbol for bitwise not. So and is same for logical and bitwise. Only thing, how many times you write that and. Xor is this caret. You'll find all this on your keyboard. Okay, these characters. This is called tilde. It is used for actually what happens in bitwise, there is no not. It is actually called as one's complement. So I'll explain it to you now. So in bitwise operation, whenever we want to do bitwise operation for, especially for the not operation, or you can say complement operation. Now there is something that the computer follows, which we humans do not follow. So what the computer does is, whenever you want to find the complement, it is called as one's complement, or you can say not operation. Not operation is nothing but reversing the bits. Okay, bitwise means what? At the bit you will perform the operation. So 6 is what? 0, 1, 1, 0. So bit by bit, you have to perform the not operation. Not operation means what? Negation. Negation means nothing but reversal. Reversing means nothing but changing 0 to 1, and 1 becomes 0. Okay, 0 becomes 1, 1 becomes 0. So if you solve only till here, it is nothing but you'll say the answer is what? 1001, that is 9. You may say the answer is 9 for negation 6, or you can say 1's complement of 6 is 9. That is correct. But the computer will never store 9 inside its memory when you perform negation 6. So if you print out the value of negation 6, if you print out this, if you print out 1's complement of 6, you will not get 9. You will get -7. Why? Because I've explained it in the video also, but I'll tell you now. See, the shortcut to do this is, whenever you do not 6, the answer how it will come is 6 plus 1 and put a minus sign here. So this is the formula to calculate the NOT operation, or you can say complement operation for bitwise. So 6 plus 1 is 7 and minus sign is there, so minus 7. Similarly, you have asked me for 40. So when I say not 40, okay, not 40 means 1's complement of 40. At the bit level you'll get some answer theoretically. But the computer, which answer it will display to you? It will display minus 40 plus 1. 40 plus 1 is what? 41, and minus is this, so minus 41. So minus 41 you'll get at the output. This is because the computer will store the result in the form of 2's complement. For example, the value of 6 is what in binary? 0, 1, 1, 0. 1's complement means you're reversing the bits is what? When I do 1's complement, means 1's of 6 is nothing but 1, 0, 0, 1. If you want to find 2's complement of 6, what you'll do? Do you know how to find 2's complement of a number?
Plus 1.
Very good. Very good. So 2's complement of 6 is nothing but do plus 1 to its 1's complement. So plus 1 means it is actually plus 0, 0, 0, 1. So you know the operation, I suppose. 1 plus 1 is 0 carry 1. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus 0 is 1. So as you can see here, 1, 0, 1, 0. So this is what 8 and 4, 2. 8 and 2 is 10. Right? 8 and 2 is 10.
Yes.
Yeah. So this is what it will. It is the 2's complement. Now this 2's complement, if you reverse the digits, okay, then it gets into the actual answer that you'll get into your output. So actually I've explained it very much in detail in the video. So you once go through that video, because I don't have that PPT right now with me, otherwise I can show it to you nicely. So you go through that video and then next time live we'll discuss it, because I don't have that PPT right now. Is it okay?
Okay, sir, it's okay.
Yeah, but the shortcut is what? Minus 6 plus 1. Okay, that is the shortcut.
Yes, sir, got it.
Yeah, so we can end this now if you don't have any more doubts.
Yes, sir.
Okay, thank you for attending.
Thank you.
Welcome.